Guys, this is the review for your test tomorrow. So on number one, check the review to get the answers, but there's a number of things you could do. You could do solar energy, solar panel converts solar energy into electrical energy, hydroelectric dam converts potential energy of the water into kinetic energy, into mechanical energy to spin the turbine, into electrical energy. You got a chemical energy for a battery. Geothermal energy converts heat basically into steam, into mechanical energy, into electrical energy. Same for coal. Nuclear power uses fission to convert to heat up water and then eventually convert that into electrical energy. So there's several of those you can use. That's just some of the examples I used. Number two, a person is pushing a large box along the level floor, applying a horizontal force of 206 newtons. If the person pushes the box a distance of 5 meters in 1.5 seconds, how much work did they do? So work is equal to force times distance. So you're just going to do 890 times 12. Oh, sorry, that's the wrong one. So you're just going to do 206 times 5, and you get 1030 joules. The 1.5 seconds is extra information that you don't need. A conveyor system at the local packaging plant will utilize a motor-powered mechanical arm to exert a force of 890 newtons to push a distance of 12 meters in 22 seconds. Determine the power. So you need to know work is equal to force times distance. You also need to know power is equal to work divided by time. So you can plug this in, force times distance over here, and you get power is equal to force times distance over time. So what I'm going to do is plug that in. Force is 890 newtons times the distance it's lifting it, which is 12 meters, divided by the time, which is 22 seconds. And if I plug all that in, I get 485 watts. Alright, number four, a mechanic used a hydraulic lift to raise a 15,064 Newton car 2.38 meters. It took 7.63 seconds. What was the power? So again, power equals work divided by time. Work equals force times distance. So we're going to use power equals force times distance over time because we're just plugging this in to work. So power is equal to 15,064 newtons times 2.38 meters divided by 7.63 seconds. And that's equal to the power output, and that number should be 4,700 watts. Now I rounded that somewhere around there. It's not exactly that. Number five, a woman lifts a 20 kilogram object 30 centimeters each time she does a particular exercise. If she takes 0.8 seconds to lift her weight, how much power does she supply? Well, the thing that you need to know, you need a force, okay, because we've been doing this the whole time. We need a force, and the force that you're going to get is equal to the force of gravity that she's lifting, and that's mass times 10. So the force is going to be equal to 20 times 10, which is 200. Okay? And then we're just following with what we did before. So you're just trying to find power. So power is equal to work divided by time, and work is equal to force times distance. So you plug in force times distance, so power is equal to 200 times 0.8, because you got to convert it to meters. Oh, not 0.8, 0.3, sorry. And then divide that by time, which is 0.8. And you should get the power is equal to 75 watts. Okay. Number six, I'm just going to define these. Potential energy is the stored energy in a system. Gravitational potential energy is potential energy based upon the height of an object. And elastic potential energy is the potential energy that is stored in a spring. Number seven is what makes up mechanical energy. The answer to that is potential energy plus kinetic energy. The force on an object has to be parallel for the object to do work, force parallel to the displacement. That's what's supposed to go in the blank. I realize it's a small blank, but that's what's supposed to go there. So the force has to be parallel to the displacement. Number 9, how much work is done on a 175 Newton boulder that you carry across a room? So if this is you, and you have a boulder in your hand, the force that you're using to hold that boulder up is that way. But if you're moving it horizontally, you're moving it this way. So your force is this way, and your distance is this way. And if we look up here, parallel to the displacement for work to be done, what that means is there is 0 work done. Okay? And if there's 0 work done, then work is equal to change in energy. So if there's 0 work, there's 0 change in energy, so there can be no gain in potential energy. So both A and B are 0. Because work is equal to the change in energy. 0 work, 0 change in energy, so the potential energy would stay the same. Number 10, you've got a 2 kilogram ball. Kinetic energy is 80 joules. Find the velocity. Kinetic energy equals 1/2 mv squared. So 80 is equal to 0.5 times 2 times v squared. 0.5 times 2 is 1. So 80 is equal to v squared, square root, and v would be 8.9 meters per second. Number 11, explain the law of conservation of energy. Essentially, it boils down to the energy at the beginning has to equal the energy at the end. Okay? So the energy you have at the beginning of a problem has to equal the energy you have at the end of the problem. And that's, in essence, all there is to it. Number 12, what is the work energy theorem? So the work energy theorem is work is equal to the change in energy. So that's one of the formulas you'll need. You can also use this formula, force times distance, that's how you calculate work, is equal to energy final minus energy initial, which is the change in energy. And number 13, what is the speed of a 75 kilogram woman with the kinetic energy of 1500 joules? So, again, kinetic energy equals 1500 joules, and that's equal to 1/2 times the mass of the person times the velocity squared. Solve for V. It should be equal to 6.3 meters per second. Okay. Number 14. A small jet aircraft has a mass of 8,000 kilograms. It needs to reach a speed of 70 meters per second to take off. If it is intended to be used on a runway that is 270 meters long, what would be the accelerating force? So we're looking for force. Since we're looking for force, we know we're going to have to at some point use the work is equal to the change in energy formula. Okay? Because you are changing this object's energy. You're going from not moving to moving. So the kinetic energy is changing. So work is equal to force times distance, and the change in energy will be the change in kinetic energy. So force times distance is going to equal 1/2 mvf squared, the final kinetic energy, minus 1/2 mvi squared, the initial kinetic energy. Now the initial kinetic energy is 0 because the thing is not moving. So this is 0. So you're left with force times 270 equals 1/2 times the mass, which is 8,000, times the velocity squared, which is 70. And then you solve for F. So F is equal to 75,592 newtons. Number 15. On this one, a child is swinging in a garden swing. At the lowest point, the speed of the swing is 3 meters per second. The mass of the child in the swing is 40 kilograms. How high above the low point will the child swing? So on this one, there's no force involved, so we don't have to use work equals change in energy. We can use energy 1 equals energy 2. So what type of energy does the kiddo have at the bottom of the swing? Well, he's going a certain speed, so that means that he's got to have kinetic energy. So kinetic energy equals 1/2 mv, the kinetic energy at the beginning, initially, equals the gravitational potential energy at the end, which is this height. So he's got kinetic energy here and gravitational potential energy here. Alright, so we end up with 1/2 mv squared equals mgh. Now notice what happens with the m's. They cancel out, and you're left with 1/2 v squared equals 10 times h. And 1/2 times 3 squared equals 10h, and h is equal to 0.45 meters. Okay, next one, 16. How much work was done by the wind? Well, the wind applied a 200 Newton force for 1,000 meters, so work is equal to force times distance. That would be equal to 200 times 1,000, which would be 200,000. 200,000 joules of work. B, how much kinetic energy did the boat acquire? You could say that this is the change in kinetic energy. So the amount you acquired is the amount it changed. Remember that work is equal to the change in energy. So work would be equal to the change in energy. Work was 200,000, so the change in kinetic energy would be 200,000. And the last one is, how fast is the boat going at the end of the 200 meter, or sorry, at the end of the 1,000 meters. So on that one, you're just doing kinetic energy equals 200,000 joules. And so you do 1/2 times the mass of the boat, which is 200 kilograms, times velocity squared equals 200,000. And then you solve for v, and you get v is equal to, sorry, hang on, 44.7 meters per second. Okay, so there you go. Basically, the way that works is you end up getting 100 v squared equals 200,000. Divide by 100, and you get v squared equals 2,000, and then you square root it. Alright, number 17. If a spring has a spring constant of 350 Newton meters, how much energy is required to compress it? 27.5 centimeters. So you do you do elastic potential energy. That formula that we learned is equal to 1/2 kx squared. K is the spring constant, so it's 1/2 times 350 times x squared. X is the distance it's compressed, but it has to be in meters, so that's 0.275 squared. And you should end up getting, if you plug that into a calculator, 13.2, and that would be, the unit would be joules. 18. What is the average power supplied by a boy that is running up a flight of stairs rising vertically 3.8 meters in 3 seconds? So the first thing you got to know is the force is equal to the force of gravity on that kid. So he is 32 kilograms. 32 times 10 is 320. Okay, then we got, if we go back here a couple pages, one more. Power is work divided by time, and then power is equal to force times distance divided by time, because work is force times distance. So that's what we're going to use. So we're going to use force times distance divided by time equals power, which means that 320 times the distance he went up, which is 3.8, divided by the time, which is 3.3, equals the power. And if we do that, the power should be 368 watts. Number 19. As the tires of a braking car skid across the road, is the mechanical work done on the car positive or negative? It is negative because it's slowing down. Number 20. An out-of-control shopping cart rolls down a hill and runs into a car, bringing it to rest. At the top of the hill, what kind of energy did it have? It had gravitational potential energy at the top of the hill. At the bottom of the hill, it had kinetic energy, because it was moving. Number 21. A boy pushes a 5-kilogram cart in a grocery store, starting at 0.5 meters per second, accelerating to 3 meters per second. How much work was done on the cart? Well, work equals the change in energy, and so work is going to be equal to the change in kinetic energy in this case, because it's a moving object. So force times distance equals 1/2 mvf squared minus 1/2 mvi squared. So if we do this, we get force equals or sorry, my bad. We're just looking for work, aren't we? So we don't have to worry about this. We can just do work is equal to 1/2 mvf squared minus mvi squared. So the work would be equal to 1/2 times 5 times 3 squared minus 1/2 times 5 times 0.5 squared. And if you solve that, you should get 21.9 joules. 22 is a similar problem. So what you have is you have a box that starts off at 5 meters per second and then comes to rest. So we're doing work equals the change in energy, and that's force times distance. So we have to deal with this one because we actually have a force involved here. Force times distance equals the change in energy. The change in energy will be the change in kinetic energy again because it's moving. And so force times distance is equal to kinetic energy final minus kinetic energy initial. Now the final kinetic energy is going to go to 0 because it comes to a rest, comes to a stop. So we end up with force times distance equals 1/2 mv squared, and that's the initial velocity squared. So we get 20 times distance is equal to 1/2 times 30 times 5 squared. And if we solve for d, we should get 18.75. Okay, and last one but not least, a toy car moves with a kinetic energy of 30 joules. If its speed is doubled, what will its kinetic energy be? So we got the formula 1/2 mv squared. So if I double v, alright, if I double v, you would get 1/2 mv m2v squared. Now notice, instead of there, like if we just pretend there's a 1 here, whoops, we pretend like there's a 1 here. If you square the 1, you just get a multiple of 1. But if we square the 2, we get a multiple of 4. So the thing will be 4 times more energy. Now we know that it's 30 joules, so 30 joules times 4 is equal to 120 joules. So the important thing here is it asks you what happens if you double the velocity. Then if you double the velocity, you got to square what, like basically whatever you do to the velocity, you square that, and that's what happens to the energy. So if we tripled the velocity, the energy would go up by 9. If we quadrupled the velocity, the energy would go up by 16. If we increase the velocity by a factor of 5, the energy would increase by a factor of 25. Alright? If you have any questions, feel free to let me know. And good luck on your test.